Okay, so in this video, I want to start by just introducing the concept of complex numbers. So complex numbers seem a little strange. They seem a little counterintuitive, but we're just going to kind of run with this, and there's just a few definitions we need to go over, and we should be able to do quite a bit with just these couple of definitions and what we already know. Okay, so we say that the square root of -1 is equal to I. Okay, so now what we're doing is we're allowing ourselves to do something with the square root of a negative number. Okay, so we just call the square root of -1 I. Okay, and therefore we have I squared is equal to -1. You can think of that as the opposite of the square root, right? So now if we take I and we square it, we can actually get a negative number by squaring some number, right? But it has to be I. Okay. And we have, if let's say we have the square root of -a, where a is some real number, some positive real number, then this is equal to I times the square root of a. Okay, and this is because we have you can think of this as the square root of -1 times a, which is the square root of -1 times the square root of a, which is equal to I times the square root of a. Okay, so these are a couple of basic definitions we need. And also, the general form of a complex number is not just the I part of it. Generally, we have a plus b times I. And we say that this first number here, this a, is the real part, okay? And the second part, the b, is the complex, or sorry, the imaginary part. Complex or imaginary part. Okay, I use imaginary. This is the imaginary part, okay? Kind of unfortunate phrasing because really these numbers are used all of the time in real world applications. They're not imaginary, they are real. But that's what we call them. We call them the imaginary part of a number, okay? Um, yeah, so now we are going to take some of these basic facts and see what we can do with this. So let's start with a really easy example. Let's say we have the square root of -13. Well, we can just go ahead and write this as the square root of -1 times 13, which is equal to the square root of -1 times the square root of 13, which is the square root of 13 times I. Okay? Or you can just pull out the negative sign and call it 13 times the square root of I. That's also fine as well. Similarly here, we can have I times the square root of 4, which is just 2 times I. Okay, so these are really quite simple. These are going to go about how you'd expect them to go. Okay, this is a little more complicated, but let's see what we can do here. The square root of -12. Well, first we're going to deal with the negative part of this. So this will be I times the square root of 12. But we can simplify the square root of 12, right? So this is equal to I times the square root of 4 times 3, which is equal to I times the square root of 4 times the square root of 3, which is equal to 2I times the square root of 3. And it's usually customary to write the I last. So we can write this as 2 times the square root of 3 times I. That's usually how we would write that. Okay. You're not wrong if you write it before, but usually that's the way we would write that. Okay, so now let's do a few basic operations. What if we want to multiply or divide some negative square roots, right? What about this one? Here we have the square root of -42 times divided by the square root of -7. Well, usually it's a good idea to start by dealing with the negative components here. So we would rewrite this as I times the square root of 42 over I times the square root of 7. Now, we notice that we have a weird rule for multiplication. If we square I, we get -1. But division works about how you'd expect in some ways. So if we have I divided by I, that's just going to be 1 as well. I over itself is 1, so we can actually just go ahead and cancel those. And now we're left with the square root of 42 over the square root of 7. Okay. So now if we go ahead and combine these two, we will get the square root of 6. That's just because we have the square root of 42 divided by 7, which is 6. So square root of 6 is going to be your answer here. What about the square root of 8 times the square root of negative 8? Well, again, we have to deal with the I first. So this will become the square root of 8 times I times the square root of 8. Okay, so this becomes I times the square root of 8 squared. Okay, but that undoes the square root, so we're going to end up with 8I. Okay, how about the square root of negative 14 times the square root of negative 2? Well, again, deal with the i's first. So the square root of negative 14, that's I times the square root of 14. And then we have the square root of negative 2 is I times the square root of 2. So now let's deal with these two i's here. So if we have these two i's, we have to square them. So we have I squared is equal to, times the square root of 14 times the square root of 2. But if you go back up to that initial rule we had, if we have I squared, it's equal to negative 1. So with that, we can just rewrite this as negative 1 times the square root of 14 times the square root of 2. Okay, so we can combine all this together, so we'll end up with negative the square root of 14 times 2, which is 28. And we can divide that up as negative the square root of 4 times the square root of 7. 7 times 4 is 28. So we get negative 2 times the square root of 7. And that would be your final answer here. Okay, so now let's go ahead and deal with adding and subtracting complex numbers. So, like I said up at the very top there, if we have a complex number of the form a plus bi, okay, where this is the real part, this is the imaginary part, a is the real, b is the imaginary. If we have a complex number of that form, and we want to add it to another number, say c plus di, this is going to work maybe a little bit differently than you might expect. What you're going to do is you're going to add the real parts together and you're going to add the imaginary parts together. So how this would look is we're going to write this as a plus c plus b plus di. Okay, so this is how addition works with complex numbers. So you add the real parts together, then you add the imaginary parts together, and that's how this is going to work. So it's a little easier to see when we actually do it in practice. So here we have 4 plus 2i plus 3 plus 4i. So let's start by adding the real parts together. The real parts are 4 and 3. So if we have 4 plus 3, that's going to give us 7. Okay. And then if we have 2i and then 4i, we'll have plus 2 plus 4 times I. That's going to give us 7 plus 6i. So if we add these two complex numbers together, we get 7 plus 6i. Okay, subtraction is a little different. It's not too different, but it works about how you'd expect in terms of parentheses and everything, right? So if we have 3 minus 6i minus 4 plus 2i, we have to distribute this negative sign like we normally would, okay? So this would actually become 3 minus 6i minus 4 minus 2i. And so now we can, I guess another way to think of this would be actually like combining like terms. For the purposes of adding and subtracting complex numbers, you can kind of treat I like it's a variable. You have to remember it's not a variable, but in terms of how it functions in terms of addition and subtraction, you can kind of think of it like one. So you combine like terms. So we have the two constant terms here, 3 and negative 4. So 3 plus negative 4 is equal to negative 1. And then we have negative 6i minus 2i. That's minus 8i. Okay. Now let's do 3 plus 2i plus 6 plus 4i. Okay. We can do our combined like terms, I suppose. 3 plus 6 is 9. And then 2i plus negative 4i is minus 2i. Let's look at one more. Here we have 6 plus 7i minus 2 plus 7i. So let's go ahead and distribute that negative sign. And we'll get 6 plus 7i minus 2 minus 7i. If we combine like terms, we get 6 minus 2, which is 4. And then 7I minus 7I, these will actually cancel. So our actual answer between these two here is just 4. Okay, now let's look at multiplying complex numbers. This also isn't too bad. This is going to work exactly like you'd expect it to. It's going to be the usual foiling. We have an expression. You can still sort of treat the I like a variable, but remember we have to remember when we're multiplying complex numbers that I squared is equal to -1. That's going to be the one trick here for remembering how to evaluate these expressions. So if we have -4 plus 2I times -5 plus 2I, let's just go ahead and FOIL this out like normal, and then we'll simplify it as much as we can. So start with our firsts. So I have -4 times -5, that's positive 20. Then we have our outers, so -4 times I, that's minus 4I. Then we'll have 2I times -5, that's going to be minus 10I. And then we'll have 2I times I, that is going to be plus 2I squared. Okay, and now let's see if we can simplify this. So we can start by combining like terms. So we'll have 20 minus 14I plus 2I squared. But remember, I squared is equal to -1. So this is actually 20 minus 14I plus 2 times -1. Or we have 20 minus 2, I suppose, how you think of that. So we'll have 18 minus 14I. And that's going to be your answer. Okay, how about this one? Here we have -4I times -5 plus 3I. Okay, so with this one, we can just distribute like we normally would. So we'll take the -4I to each of these, and we'll have -4I times -5 plus -4I times 3I. Now let's simplify this. -4I times -5 is going to give us that's going to give us positive 20I. And then if we have -4I times -3, that'll give us -4I times 3, that's going to give us minus 12I squared. Okay, but that I squared becomes a -1. So I have 20I minus 12I times -1, which is going to give us 20I plus 12I. I'm sorry, we shouldn't have an I there. I think I squared becomes -1. So this would actually, let's just back up a little bit. Let's start this over. Okay, so we have 20I minus 12I squared. So this is going to be 20I minus 12 times -1, which is equal to 20I plus 12. And remember, like I said before, usually it's customary to write it in the form A plus BI. So usually we would write this as 12 plus 20I. And again, you're not wrong for writing as 20I plus 12, but 12 plus 20I is the way it is usually written. So I would encourage you to write it that way. Let's do another one. Here we have 6 minus 2I times 1 plus 2I. Sorry, 1 plus I. So we can FOIL this out like normal. So we'll have 6 plus 6I minus 2I minus 2I squared. Okay, we can combine like terms and we get 6 plus 4I. And that I squared becomes a -1, so we'll have minus 2 times -1. And that's going to give us 6 plus 4I plus 2, which is equal to 8 plus 4I. Okay, let's do one more. 1 minus 5I times -3 plus I. Okay, if we do our usual foiling, we get -3 plus I. Okay, then we have so our first outers, and then we have our inners. So -5I times -3 is going to give us plus 15I. And then we have minus 5I squared. So here we have -3, okay, plus 16I. And then we have minus 5 times -1 because I squared is -1. So we get -3 plus 16I plus 5. So if we combine -3 and 5, we'll get 2 plus 16I. Okay, so now we're going to do the one thing with complex numbers that is actually quite a bit different. This is a much more complicated process. So adding, subtracting, multiplying, these are all things that should make quite a bit of sense. There's a couple of twists to them, but really they're about what you'd expect as long as you understand the basic rules of complex numbers. So where things get a little weirder is when we're talking about dividing complex numbers. Okay, so this is where we have to remember something we talked about a couple of videos ago, and that is the conjugate of a complex number. So we have the conjugate. If we have a complex number of the form a plus bi, this is a minus bi. Okay, so all we're doing is we're changing this middle sign. If you have this this expression a plus bi, the conjugate is a minus bi, and we're going to remember this because if you remember correctly, we have that if we have a plus b times a minus b. So when we have the if we have a number multiplied by its conjugate, we're going to get a squared minus b squared, right? That ends up being very powerful here because when we're dividing complex numbers, our goal is actually to eliminate the I variables from the denominator. Okay, and if we use conjugates, we're able to do that. So we're going to use this to help us out here. So let's go ahead and get started. So just like how we removed the square roots from the denominator before, now we're going to use this to remove the I, the imaginary components from the denominator as well. Okay, so here we have 4i divided by 6 plus 3i. So to start with, let's go ahead and multiply this by the conjugate of the denominator over itself. So we'll have 6 minus 3i over 6 minus 3i. Okay, so if we do the numerator, all we have to do is just distribute that. So we'll have 24i minus 12i squared. Okay, that's fair. And then in the denominator, now we have to, we can either FOIL it out or we can do our a squared minus b squared because we have our conjugates. I'm going to do the a squared minus b squared. So we'll have 6 squared minus 3i squared. Okay? So on the numerator, we're going to have 24i minus 12 times negative 1. And this is going to be over 36 minus 9 times negative 1. Okay? So that's going to give us, looks like it'll be 12 plus 24i over 36 plus 9. Okay? 36 plus 9 gives us 45. And then now what we do, you can stop here. I'm not necessarily opposed to that, but a more proper way to write this would be to write the real and the imaginary parts as separate. So we can divide this up as 12 over 45 plus 24 over 45i. Okay, I'm just going to move this over because we can actually simplify this quite a bit. We can notice that 45 and 12 are both divisible by 3. So we're going to end up with 4 over 15 if we divide them both by 3. Okay, and then we also have this is also divisible by 3. This is going to give us 8 over 15i. Okay, so that is how this is going to look here for your final answer. Okay, now we have 3 plus 3i divided by negative 4 plus 6i. Okay, so let's go ahead and see what we can do here. So what we're going to do is we're going to multiply it by the conjugate of the denominator over itself. So remember, conjugate, we just changed the middle sign. So we'll have negative 4 minus 6i over negative 4 minus 6i. And I repeat myself a lot on this, but it's important. The reason we can do this and not change anything is because we're multiplying by 1. That's all we're doing. We have negative 4 minus 6i divided by negative 4 minus 6i. That's just 1. All we're doing is rewriting this in a creative way. Okay? So Let's go ahead and FOIL. Let's actually have to FOIL the numerator here. So we'll end up with, if we put parentheses, we can probably see it a little easier. We'll do our firsts. So we'll have negative 12. Then we'll have minus 18i. Then we'll have minus 12i. And then we'll have minus 18i squared. This is all going to be over the denominator, which is now going to become a squared minus b squared. So we'll have negative 4 squared minus 6i squared. So this will become negative 12 minus 30i, and this will become plus 18. Okay, because this becomes 18 times negative 1, which is minus 18. So minus a minus 18, that's plus 18. Okay, over 16 minus 36 times negative 1. Okay, so negative 12 plus 18, that's 6 minus 30i over 16 minus a negative 36, or 16 plus 36, which is 52. Okay, so let's go ahead and spread this out. So we can rewrite this as 6 over 52 minus 32, or sorry, 30 I over 52. Okay, so we can simplify this just a little bit. So we'll notice that these are both divisible by 2. So if we divide by 2, we'll get 3 over 26 minus, and then 30 and 52 are also divisible, sorry, also both divisible by 2. So we'll get minus 15 over 26i. Okay, let's do one more. Here we have 4 plus 4i over negative 4 plus I. So let's go ahead and do the conjugate of the denominator over itself. So we'll have negative 4 minus I over negative 4 minus I. And the numerator is going to become the product of these two. So we'll have minus 16 minus 4i minus 16i minus 4i squared. And the denominator is going to be a squared minus b squared. So we will have negative 4 squared minus I squared. Okay, so this is going to become negative 16 minus 20i, and this will just become plus 4 because I squared is negative 1. This will all be over 16 minus negative 1. So that'll become, we'll have negative 16 plus 4. Negative 16 plus 4 is going to be negative 12 minus 20i over 16 minus negative 1 is going to give us 16 plus 1, so 17. So our answer is going to be negative 12 over 17 minus 20 over 17i. And I think that's about as good as you're going to get as far as simplification goes.